Hello scholars, welcome back. This is Primer's classroom and this is the third class in physics where we will be talking about motion. In the previous classes we have talked about measurement, we have talked about scalars and vectors. And in this class I want you to really take your time because we are going to break down every concept in motion, and at the end of each class we are going to be solving questions on all of those concepts. I'll make sure I solve all of the questions that you are probably going to see in your exams with you so that you understand the concept clearly. So sit back, relax, get your books and get your pen and let's get started. Now, when you're talking about motion, we're going to talk about the definition of motion, the classification of motion, the types of motions. Then we're going to talk about rectilinear motion properly. Then we'll look at the terms used in describing rectilinear motion. Then after that, we'll look at equation of motions. So I'm going to be deriving the equation of motions, and we use all of these equation of motions to solve problems in physics. So let's get started. Now, when you're talking about motion, motion is simply defined as the change in position of a body with time. If I leave this position and I move, you can already see that I'm in motion. I'm changing where I was before to a new place. So that is called motion. You probably leave your home and you go to school, you leave your home, visit your friends, you move from one place to another, and that is simply called motion. For example, someone pulling a wheelbarrow is on motion. An apple falling down from a tree is on motion. The body sliding down that inclined plane is on motion. Also, someone on a skate moving from one place to another is also in motion. So, motion is simply defined as the change in position of a body with time. So, get to know that. Then the second thing you have to know is that when we're talking about motion, there are ways in which we classify motion. So, talking about the classification of motion, I can change the position from one place to another, and you will not see any force being applied when I'm changing the position. So that gives us two classification of motion. So we have what we call kinematics and we have what we call dynamics. Now, based on kinematics and dynamics, I'm going to be breaking down all of the topics into different forms. So you see all of the things we want to do and what we want to cover in motion. So let's start with the word motion. Now, motion is classified into two. So based on classification, motion can be classified into one, kinematics. Kinematics, what does it mean? I will talk about that. Then can be classified into dynamics. So this is just going to be a general overview of everything we will talk about in motion. So just follow through. Now at the end of the day, I'm going to take them one after the other. It might not be all in this class, but so that motion is a very wide topic, so that you understand the concept clearly. So now, when you're talking about kinematics, what's the difference between kinematics and dynamics? If I study motion, just how a body is moving and all of those things, then I'm talking about kinematics. I'm moving from here to there, just how I am moving is what I want to know. The distance I covered, the speed I move. So the study of motion without referring to what is causing the motion is what we call kinematics. The study of motion without referring to the force causing the motion. But look at this. If I do this, this is a box on the table. Now I push this box, then the box moves from here to here. So looking at what I've done there, what have I done? I applied the force to push that body. Now the force I applied to push this body, it is obvious. This body did not just leave this position, it left this position and changed to this position. Then I have applied the force. So when you are talking about motion without referring to that force, this body can just decide to move from here to another place. So you can just be talking about, oh, how far did you go? So nobody is pushing the body, although there is a force in play, but we are not even going to talk about the force. So the body is now somewhere around here, changing position from A to B. So when you're talking about motion without referring to the force causing the motion, then we call it kinematics. So we don't talk about force here. Then when you're talking about motion referring to the force that caused the change in position, then we call it dynamics. So there is force. So now, based on this, we're going to study a whole lot under kinematics and we're going to study a whole lot under dynamics. Now, based on dynamics, we have what we call, based on this force, force is actually defined like a push or pull on a body. But now, it is not all forces that involves push or pull. So let's see, we have two types of forces. We have what we call contact forces, and we have what we call non-contact forces. Now, under dynamics, there is a change in position of a body, and we are trying to study the force that's causing that change in position. What made this box to move from here to here is because you applied a force. So that force you are applying, are you touching that box before the box started moving? Yes. Then that is called a push. Now, because you touch the box, then we call it a contact force. Now, look at this marker. So the marker falls down under gravity. So now this marker falling down under gravity, you can't see any force pulling it down. The body just keeps moving down itself. Then we call that non-contact force. So there are some forces. You can take a magnet, put it close to another magnet. You see that one will attract the other, and they are not even touching at all. So such force is called a non-contact force. So the type of force in which that requires touch, we call it a contact force. The one that do not require touch, we call it a non-contact force. So you need to know examples of these forces. They can ask you. So example of contact forces are reaction force. We have what we call reaction force. Like if I place an object on the table, the weight will act downward. Then this table where I'm placing the object will also be pushing the object upward. Then we have this. So that is called a reaction force. We're still going to talk about that. I just push this body now. So the force of push is also what? A contact force. When a string is pulled down, the tension in that spring is called a contact force. So you need to know that these are types of forces. So we are talking about the types of forces now, which is contact and non-contact forces. Examples of contact forces are push or pull. So you can pull something towards you, you can push something. That is a contact force. Another example is force in a string or spring. We call it tension force. So in a rope, you stretch a rope, then that rope keeps stretching. So we call it tension. Then when you place a load on a table, then the load rests on that table and the table is also pushing against the load. We call it a reaction force. So there are a whole lot of forces that are called contact forces. Even drag force, like a frictional force, is also a contact force. So the examples of non-contact forces are also called force fields. They are also called force fields. So examples are your electric forces, you have magnetic force, you have gravitational force, you have the force on a magnet. So every time you hear field, all those fields are generally non-contact forces. So that is the thing. So now we are still on the general overview. So I only define motion as change in position of a body with time. Then I say when you're talking about motion, you can study motion without talking about the force that is causing the change. That is called kinematics. Then you can study motion referring to the force causing that change. Then that is called dynamics. So what are the things we're going to look at under kinematics? So let's see on the quick summary. So if you're studying kinematics, we're going to now focus on what we call rectilinear motion. So we'll be studying rectilinear motion, which means motion along a straight line. This will be the thing we're going to talk about today all through, explaining all the equations of motion, the types of motion, acceleration, uniform acceleration, and all of those terms we use. That is under rectilinear motion. Then after studying rectilinear motion, you study what we call graphical motion. Graphical motion. So all of these are under kinematics. You see that when we are talking about this, we're not going to be talking about any force involved. Then after graphical motion, we're going to talk about motion under gravity. Motion under gravity. Then after motion under gravity, we talk about projectile motion. So I'm going to take all of this one after the other. Rectilinear motion, graphical motion, motion under gravity, and projectile motion. So we're going to deal with them under kinematics. Then under dynamics, we're going to be talking about the Newton laws of motion. So that's when we start the Newton's laws. Then after the Newton's laws, I'm going to talk about the circular motion. But don't forget, under the Newton laws, we have several applications of Newton laws. So I'm going to spend, motion is very, very wide. You see as we are moving on, just calm down, you will understand everything one step at a time. And we're going to be solving questions for you to check if you really understood or not. So when we're done with circular motion, we'll move on to SHM, which is simple harmonic motion. It does not look simple, but the word says simple. But I will make it try to be very simple for you to understand. I will solve problem on a lot of simple harmonic motion. So these are the parts we're going to be looking at under motion. So we'll take them one after the other and we deal with them all through. So when you're studying all of these guys I have here, we're not going to be talking about forces. When you start talking about these guys, we'll start talking about forces. Restoring forces, centripetal forces, and all those Newton laws of forces and all of those things. So that's what we're talking about. This is the overview of motion. Now that you know about motion, let's talk about the types of motion that we have. So what are the types of motion we have? Because I just moved along a straight line, that is a motion. So now, what are the types of motion? We have what we call a translational motion. Translational motion. Translational motion is simply talking about motion along a straight line. So a man walking along a straight line, just like the way sodium is walking along a straight line. So that is translational motion. So when an object moves its rigid body along a straight line without changing any part of the body, then that is translational motion, a motion along a straight line. Then we have what we call a rotational motion. When you say rotational means the body is, you have seen a fan before, that fan keeps moving about its axis, about its own axis. So it keeps rotating about that origin, then it keeps moving round and round about its own axis. Then we call it rotational motion. So if you have the earth too, the earth keeps moving round and round and round and round. So the earth keeps moving about its axis. So the motion of a body about its own axis is called rotational motion. Then example is like the fan blade. So the fan blade, the earth's movement about its axis, that is an example of rotational motion. Now, even a wheel of a vehicle, the wheel of a vehicle can exhibit rotational motion too. Now, another example of the type of motion you talk about is oscillatory motion. Oscillatory is also known as vibrational motion. So please follow through. We have a lot to do. So now, vibrational motion is another example. And whenever you hear the word to and fro, so a body keeps moving forward and backward, keep vibrating. That is what we call vibrational or oscillatory motion. The to and fro movement of a body about its equilibrium position. So we call it vibrational or oscillatory motion. An example is the talking drum. So when talking drum is being beaten, it keeps vibrating here and there. The diving board is also another example. The balance wheel of a watch is also another example. Then a simple pendulum. So you take a simple pendulum, you displace it, it has a bob, you displace the bob from equilibrium position to a position. So when you let it go, so it keeps moving like this. So it keeps going forward and coming back, forward and coming back. So it keeps going to and fro about this equilibrium position. So we call it oscillatory motion. Another example is mass on a spring. So when you have a spring, then you load that spring with a mass and you pull this spring. You will realize that this spring will keep going up and down, up and down. That is also oscillatory motion. We're going to talk about that a lot under simple harmonic motion. Then we also have what we call a random motion. Random, the word random, when something is random, it means you cannot really tell the direction. So it keeps moving haphazardly, it keeps moving irregularly, it keeps moving at no particular direction. So that is what we call random motion. So the motion of a body, or the disordered motion of a body, or the random or haphazard motion of a body, or the zigzag motion of a body without a specified direction, that is what we call random motion. And there are a lot of examples of that. If you have particles inside water, those particles keep moving here and there, the water keeps carrying them, like the Brownian motion. That is an example. So then if you have gases, just release gases, those gases keep moving at random. All of these are examples of random motion. Then if you have an insect, the insect can jump from one flower to another flower, keeps moving at random, and you can't really tell the parts that the insect is moving. That is also another example. You need to note most of these examples because they can ask you in exams. So the next one you talk about that you might likely see is this circular motion. So I just want you to note the difference between circular motion and rotational motion. When a body rotates about its own axis, then we call it rotational motion. When a body rotates about the axis of another body, like for example now, there's the Earth, there's another planet moving about the Earth. So if another planet keeps moving about the Earth, then that body is undergoing what we call circular motion. So the motion of a body about another axis is what we call circular motion. But the motion of a body about its own axis is called a rotational motion. So these are the different types of motions that we have. So movements of planets around each other, movements of electron. You remember you're going to have nucleus, then electron will keep moving around the nucleus. Then that is what we call a circular motion. Movements of something about an axis of another thing, then that is called circular motion. We're still going to talk about circular motion in full and how all of these things happen. So now, knowing these types of motion now, the next thing you really want to know is that you have to be careful. Sometimes these motions can be combined. Imagine an insect. Imagine an insect moving from one flower to another flower to another flower randomly. Now, as this insect is moving, you can see that it's moving along a straight line. When something moves along a straight line, that is translational. But it changes direction again, still moving along a straight line. Now changing direction again. So it's moving at random, but it's also moving along a straight line. So the movement of that insect is going to be a combination of both translational and random motion. Now, if you have an inclined plane and you have a wheel that is rolling down this inclined plane, as the wheel is moving down, now it's the rotation of the wheel on that inclined plane is going to be rotational motion, Abi. But as it's moving along a straight line down this place, then it's exhibiting translational. So a body can exhibit two or more types of motion at the same time. Even a gas molecule, let's say CO2, that is moving at random in a container. As it's moving at random in that container, it's moving, colliding with the wall, and also moving along a straight line. So that means a gas molecule can combine both translational and random motion. So you need to understand this. When we start solving questions, we start applying them. So now, let's focus on rectilinear motion properly. Now, on kinematics, we said that rectilinear motion, we're going to study rectilinear motion, graphical motion, motion under gravity, and projectile motion. While on dynamics, we're going to study Newton's laws of motion, circular motion, and simple harmonic motion. But let's spend our energy in this class on rectilinear motion. There are a lot of things you need to understand on rectilinear motion so that the rest of the class will be very easy for you. Then when we are through with rectilinear motion, I've said it, we're going to derive the equation of motion. Then after that, we'll solve questions on all of the things we have been saying. Then we are through with that. Then in our next class, we'll now focus on both graphical and motion under gravity. And next class, we focus on projectile because I have to take my time to explain projectile for you to understand it clearly. So let's move on. So let's spend energy on rectilinear motion. So the word rectilinear motion is just talking about the motion of a body along a straight line. That is rectilinear motion. That's what we want to study. Now, when you're talking about the motion of a body along a straight line, it's usually involved, for simplicity, it usually involves a uniformly accelerated body. So we're going to be talking about a uniformly accelerated body for our terms to be very, very correct. So for now, let's see what each term talk about. So rectilinear motion is focusing on a uniformly accelerated body. So when you're talking about rectilinear motion, there are a lot of terms you will hear. So let's pick these terms one after the other. So the first term is distance. Distance versus displacement. So what is distance? Distance is defined as the total path taken. Total path taken. So the total movement of a body, the total length covered by a body is what we call the distance, the total length. So irrespective of how it moves, it is what we call the distance. The unit of distance is meter. And distance in physics can be represented as S, can be represented as D, and can be represented as X. So let's note that. Now, another thing you need to note is that distance is a scalar quantity. So it's a scalar quantity, it does not give direction. But the difference between distance and displacement is that displacement is the shortest distance between 2 points. Shortest distance between 2 points. That is what we call displacement. And you will see, when I taught you scalars and vectors, I talked about all of these things. The shortest distance between 2 points is what we call displacement. We are going to see an example soon. It is also measured in meter, but the displacement is a vector quantity. It tells us the distance and the direction. So let's understand these two, because all of these things are very important for you to understand some things when we start solving problems. So looking at these two, when we did scalars and vectors, I explained some things. We said this scalars only shows magnitude, while vector shows both magnitude and direction. So if I say a body, so if you remember this, let's look at this. The body moves 1 kilometer east, and the body then moves 1 kilometer north. Now they say find the distance. We've done this before. Then they also say find the displacement. So now we did this under scalars and vectors. If they move head to tail, how will you find the displacement? It will be from the starting point to the finish line, because that will be their resultant, Abi. So that can be called the displacement. So the displacement here, we are going to, since this place is 90 degrees, we are going to use Pythagoras theorem. So we say that d square equals 1 square plus 1 square, and d is going to be square root of 2, and that's going to be square root of 2 kilometers. So our displacement is root 2 kilometers. Let's look for distance. What will be the distance? Distance only talk about the total path taken. So it went like this. What is that part? 1 kilometer. Then what is this? 1 kilometer. So that means distance is just 1 plus 1, and that is 2 kilometers. That's what distance talks about. But for displacement, the body went from here to here, then from here to here. So it says that the shortest distance. So instead of going from here to here and going from here to here, why can't you just go from here to here? That is what displacement is talking about. That's the shortest distance between 2 points. So let's say a body starts from A, then the body moves to B, then the body now moves to C, then the body now moves to D. So why do you have to go this way, this way, this way? Then the shortest distance between these points is just from this place to this place. Since you are going to D, why not go that way? Why do you have to go every other place? So displacement is just talking about the shortest distance, while distance is talking about the total path taken. So that one does not consider direction. Everywhere you take, just add everything together. That's distance. We are going to be using the two interchangeably as we move on. So please, do you understand the difference between distance and displacement? Now, distance is a scalar quantity. Displacement is what? A vector quantity. Is that taken? Let's move on to speed and velocity. So the second term, is speed versus velocity. Now, we just talked about distance. That means how far something covers. Now, speed is talking about how fast the body is moving. That's speed. How fast is the body moving? How fast? Now, I didn't say how fast and what direction. When the body moves from one place to another, how fast is it moving? That's speed. Then how fast is it moving and in what direction is it moving? That is velocity. Do you get that? So speed is simply defined mathematically as the distance covered in a given time. You know, if you are moving very fast, you will cover a lot of distance in very short time. So that is what speed is talking about. So if you did some races when you were in school, let's say you ran 100 meter and you got there in 2 seconds, but the other person got there in 5 seconds. Now, who ran faster? The person that got there in 2 seconds. So you cover the longer distance in a shorter time. That is what we call speed or velocity. So speed is defined as the speed. I will use just V. It is represented as V. It is defined as the distance covered in a given time. That is speed. While velocity is velocity, I'm putting a bar to mean that it's a vector quantity. So velocity is the displacement in a given time. Now look at these two bodies. So which means that sometimes I can do calculations and the speed will be different from velocity. They might not have the same answer. Let's check that example I gave the other time. Let's say that body moves 1 kilometer east, then 1 kilometer north. Now we say that the displacement of this body is √2, while the distance is 2. So √2 kilometer and 2 kilometer. So these values are different. If I now say that what is the speed at which this body is moving, if the total time taken is 2 seconds, just for example, so the time taken is 2 seconds. So if this is the distance 2 kilometer and this is the displacement √2, if I want to calculate speed now, speed is going to be distance 2 kilometer. You must always solve in SI units, so you can say 2 times 10⁻³ meter all over time 2 seconds. So that's going to be 1000 meter per second. So that's the speed. But what will be the velocity? Velocity is going to be displacement √2 over 2 times 10⁻³ per second. So meter per second. So if you look at this now, the answer you will get here, this will be like 1.414 something. Now, if you do this, you are going to get around 0 point something times 10⁻³, which is not the same thing as this. So you will see that the answer here is different from the answer here. So that's why you should not joke with the meaning of displacement and the meaning of distance. We will solve questions, so you see how all of these things are applied. So speed, don't forget, is distance over time. Velocity is displacement over time. Is that taken? So now, the next thing you need to know is that the units for speed and velocity, both of them, the unit is meter per second. That is the SI unit, meter per second. Don't forget that. Another thing you need to know is that speed is scalar, from what I've said, but velocity is what? Vector. So don't forget that. So those are the things you need to know about velocity and speed. But a whole lot of times you will hear the word uniform speed. Uniform speed or uniform velocity. You will hear the word average speed or average velocity. You need to know what that means. You will hear the word instantaneous speed or instantaneous velocity. Now, if you want to measure speed, have you ever been in a car with your parents before and you see on their dashboard, something is always, when they are accelerating, it will go vroom, depending on how they are moving. So that thing that you see on the dashboard is called speedometer. Speedometer. So it's going to be telling them how fast they are moving. That's what speedometer does. So we'll talk about that too as we are moving on. So now, uniform speed, average speed, and instantaneous speed. What are the differences? Let's quickly look at that. So when you hear the word average speed, average speed is defined as, physics is all about understanding the concept and doing it well. Average speed can be defined as total distance covered. I hope you are writing. Total distance covered all over the total time taken. The total distance covered over the total time taken. So the moment they say calculate average speed, just try and look for the total distance a body covers and the total time it takes the body to cover that distance. That is average speed. Another way is that if a body is under uniform acceleration, it can start from a velocity u, which we call the initial velocity, and the velocity will increase to v, which we call the final velocity. So, or it can start from velocity v1 to velocity v2. You will understand why, what has happened there. But because the more as you are accelerating, the speed will be increasing. And the moment the speed increases, so you will have a velocity you started with and a new velocity you have now. So when they now say calculate average speed or average velocity, then the average velocity is going to be v2 plus v1 over 2. Or you can say average velocity is v final velocity plus initial velocity that you are used before all over 2. So this is also called average speed or average velocity. So note these two formulas. We are going to be using the two formulas in dealing with problems. So now, that is average speed. Average speed is defined as total distance covered over total time taken, or average velocity is defined as velocity, final velocity plus initial velocity all over 2. So now, the next thing you want to know is uniform speed. So when you say uniform speed, what do we mean? The word uniform speed, anytime something is uniform, it means it's not changing. That's what the word uniform means. It's not changing. It's in equilibrium. It's balanced. So if a body starts with, a body is moving at 60 kilometers per hour. Let's say you are moving in a car and that car is moving at 60 kilometers per hour. 60 kilometers per hour means that in 1 hour, you would have covered 60 kilometers. That's the distance you would cover in 1 hour. Now, if you did not change your speed, you are still moving at 60 kilometers per hour. Then that means in another 1 hour, you will still cover 60 kilometers. So a uniform speed is talking about how you are covering equal distance in equal time interval. That is uniform speed. So a body covering equal distance in equal time interval is exhibiting what we call a uniform speed. So if I tell you that a body is moving at 60 kilometers per hour, simply this means that if the body starts from A, then when the body will get to B, if from A to B is 60 kilometers, then the time taken for that body to have moved from A to B would have been 1 hour. Then if the body will cover another 60 kilometers, let's say from B to C, it wants to cover another 60 kilometers, how many hours will it take it? Since it's still moving at 60 kilometers per hour, that same speed, then it will still cover the same thing. So it will still spend 1 hour. So for a uniform speed is defined as the covering of a body covering equal distance at equal time interval. So it covers 60 kilometers. The uniform speed now is 60 kilometers per hour. So it covers 60 kilometers in 1 hour. It covers another 60 kilometers in 1 hour. But if it changes this speed, let's say it changes it to 120 kilometers per hour. So if you increase the speed to 120 kilometers per hour, that means that where it covers in 1 hour, it will cover it in 30 minutes. Because we have to go and cover 120 kilometers. If it's going to cover 60 kilometers, it's 120 kilometers per hour. So that means that this body now, the speed at which it's moving, that means it will cover all these 120 kilometers, that's 60 plus 60. It will cover 120 kilometers in 1 hour. That means if it will cover 60, then it will only use 30 minutes. That means it's moving very fast. So that is what's happened here. But we are assuming that the body is not changing its speed. So it's covering equal distance in equal time interval. So if they ask you that what does uniform speed means, it means it happens when the body covers equal distance in equal time interval. That is uniform speed. So what do we mean by instantaneous speed? Instantaneous speed. And you can see the word instant is here. Your daddy is driving. As he's moving, he's accelerating. Now he accelerated and the body speed keeps changing. So as the speed keeps changing, someone cannot really stay on 60 kilometers, not even probably on Nigeria roads, that you might have to see gallop or you see zebra crossing, that you will have to wait for people to cross, or you slow down at some point in time. So now, when the body is moving, the speedometer, what did I say speedometer measures again? It helps you to measure speedometer. So now, the speedometer will be reading. So if you increase the speed, that means that this thing will go higher. It will show higher. Maybe it can measure from 40 to 50 to 60 to 80 to 100 to 120 to 140. Don't try to always be running around this area. It's very dangerous. So you have to run at a speed within this range, depending on how free the road is. So if you are around a very crampy road, the best is to move around 40 and 50 kilometers. So now, from what we have, your speedometer keeps showing a particular speed. So if you accelerate and you are moving faster, you put your leg on the pedal, then you are accelerating faster, then this will increase, then the car will move very, very fast. So now, that's at a particular time, this bar will be here, showing that you are now moving at 80 kilometers. At a particular time, it can be here. So it will keep telling you at a particular instant of time what your speed is at that point in time. So the speed you have at a particular time is what we call instantaneous speed. Do you understand that? The speed at a particular instant of time is called instantaneous speed. So now, we solve for instantaneous speed because anytime there's a change, a small change in something, because you really cannot tell, this thing will keep changing with time. So they cannot ask you in physics that calculates the speed when the time was this. How do you now do that? Because you can't really tell. But there's a way we do that in mathematics. We do calculus, differentiation and integration. For a small change in something, we can do calculus. So, but now, for the purpose of physics, I'll tell you how to do it. When they give you a question and they say calculate the speed at a particular time, that means they are saying calculate instantaneous speed or instantaneous velocity. So they will give you an equation like this. So this is all you need to know. In differentiation, if I give you that y is equal to x raised to power n, if I say y is working as a function of x, then that means I can say the y dx is going to give me n will come down, then that will be nx, then n minus 1. That's how you differentiate. For example, let's say I give you that d now, or x is equal to t squared. Now, if I say x is a function of time, Abi, so if I say dx dt, what would that be? 2 will come down, so that would be 2t. 2 minus 1 is 1, so it can remain as t. So what is dx dt? You remember speed. Speed is equal to distance over time. Can you see? I'm going to give you a better question to solve now. That is distance over time. So if this is distance over time, I now say calculate the speed at a particular time. Then that time, I say take the time to be 2 seconds. Then what you just do is that since you have differentiated the x dt to give me 2t, then you now put that 2. Then you say 2 into 2, then that will be 4 meters per second. So that means the body is moving at 4 meters per second. That is what we call instantaneous velocity. So do you understand how this works now? Y is equal to x raised to power n. So you differentiate then nx raised to power n minus 1, and that's the thing. So if they can give you a question like this, they can say a body is described by x equals 2t squared plus 3t raised to power 4, then at t equals to 2 seconds, what is the instantaneous speed? That means that what is the speed at that particular time? So whenever they say anything instantaneous, just know you will have to differentiate this. So if you are differentiating this, then we are going to say x is serving as a function of time. So we can say the x, the t is going to be, we say whatever is here will come down. So if it comes down, you know there's 2 here before. So 2 multiplied by 2, that's going to be 4t, because 2 minus 1 is going to still be 1, and t raised to power 1 is t. Plus, when this 4 comes out, 4 times 3, that's going to be 12. 4 minus 1 is 3, so that's 12t raised to power 3. So we have differentiated that. And the x dt is talking about speed, instantaneous speed. So meaning that distance over time. And that's what gives you this. So you now slot in the value of time, which is going to be 4 into 2 plus 12 into 2 raised to power 3. And that will give you the final answer. So let's check. So 2 raised to power 3 is going to be 8 times 12, that's 96, plus 8, that's 104. So the answer is going to be 104 meter per second. So that means that is the speed at which that person is moving at that particular time. So that is called instantaneous speed. So that's that. So let's do a quick recap. So when you say a body is exhibiting uniform speed, it is covering equal distance in equal time interval. When you talk about average speed is defined as the total distance covered over total time taken. That is average speed of v1 plus v2 over 2. That is average speed. Then instantaneous is talking about the speed at a particular instant of time, and that is measured using a speedometer. So it tells you the speed at a particular instance of time. And when you want to solve problem on instantaneous speed, you have to understand basic differentiation, saying that y is serving as a function of x. So let's move on. Now, the next one we want to talk about quickly is acceleration. Then after this, we'll derive the equation of motion. Then we'll solve questions on everything. Then we'll move on to the next class. So now, acceleration. If you and I now are to run, number one, when I define speed, when I define distance and displacement, I said the part you cover is distance and displacement. Now, for speed and velocity, I say how fast you are moving is what speed and velocity talks about. But for acceleration, imagine you and I want to run. Now, as we are running, I will be trying my best to make sure that I beat you in the race. While you two, you'll be trying your best. So when I see that you are moving kind of closer, I can try to increase the rate at which I'm moving before. So that rate at which I'm changing my speed, I'm trying to beat you. You cannot beat me, you know. So I'm trying to beat you on the race. That rate at which I'm trying to change that speed is what we call acceleration. If I slow down, that means I'm trying to decelerate. I'm trying to slow down the rate at which I'm moving. Maybe I was moving very fast, then I decided to slow down. That's called deceleration. So the rate of increase in velocity, rate means time. So the rate increase in velocity per unit time is called acceleration. Decrease in velocity for a given time. Don't just say acceleration is the rate of change of velocity. The change of velocity can be a decrease and can be an increase. And whenever it is an increase, then that is when you say acceleration. Whenever it is a decrease, then you call it deceleration. So acceleration is defined as the increase in velocity for a given time, while deceleration is defined as decrease in velocity for a given time. So you can say that acceleration is increase in velocity or decrease in velocity over time. So change in velocity over change in time, that is acceleration. Now, one thing you need to note is that if a body starts with a velocity u, usually you call u initial velocity. So if a body starts with that velocity, then that is called initial velocity. if a body attains another velocity, there's a new speed now that is moving. I was moving at 20 meters per second before, then I change it to 40. So that is called final velocity. So the new velocity I'm moving with is called my final velocity. I will usually represent it with v. So here now that I know my final velocity, I can now say the acceleration is final velocity minus initial velocity over the time it takes. That's what my acceleration would be. So we need to note this. So this can increase depending. If the final velocity is higher, then it's going to be positive, but if final velocity is smaller, it's going to be negative. But now note something. You remember I talked about uniform velocity. Uniform velocity. So I talked about uniform velocity. We said something. We said uniform velocity is when a body covers equal distance or equal displacement in equal time interval. And what does that mean? That means that if a body is moving at 60 km per hour, that means it will be covering 60 km for every 1 hour. So let's say the body starts from A now. It started with 60 km per hour to B. So this is the speed. Then it's covering, let's say 60 km per hour is what is moving. So it will cover 60 km. That means from A to B in 1 hour. That's what that means. So let's say that is you. That's what it started with. Then it's moving from B to C, still moving at that same speed. So it will cover another 60 km in 1 hour. So this is my V now. V now is still 60 km per hour. So at the end of the day, if I say find acceleration, my acceleration is going to be V minus U over T. Now what's my V? V is 60 minus 60 all over the total time, 2. And that means 60 minus 60 is 0. So that means that whenever you hear that a body is moving under uniform velocity, the acceleration will be 0. We are going to be needing this as we are moving on. So I just proved it to you why it will be 0. That's what I've done. I could have just told you. But whenever you hear that a body is moving under uniform velocity, the acceleration will be what? 0. So acceleration is defined as change in velocity over change in time. That is acceleration. So now that we have this, you can also hear instantaneous acceleration. You know, acceleration is the v dt. So if you want to check instantaneous acceleration, so what do you think that is talking about? And don't forget, you know, I already said there's what we call deceleration. So deceleration is when the speed is decreasing. You are decreasing speed with time. That is deceleration. When you are increasing speed with time, then that is called what? Acceleration. So acceleration is increase in speed for a given time. Deceleration is decrease in speed for a given time. So now, what is instantaneous acceleration? And whenever you hear the word deceleration, when we are doing calculation, you must always add negative to that A to show deceleration. We only use positive to show acceleration. We use negative to show deceleration. You will see as we'll be applying them as we move on. Now, instantaneous acceleration is talking about acceleration at a very instant of time. Instantaneous. Just like the same way I told you about instantaneous velocity. The acceleration at a given instant of time. That is called instantaneous acceleration. So they can also say, and given that x is equal to, let's solve that one we did the other time. I think I said 2t raised to power 2 plus maybe 3t raised to power 4. So if they say, what is the acceleration when the time is 2 seconds? How are we going to do that? So we're going to first differentiate this. So we'll say the x dt is going to give us 2 will come down, that will be 4t raised to power 1, plus 4 will come down, that will be 12t raised to power 3. Do you understand that? Very good. So now that we've done that, but you remember the x dt is not the same thing as the v dt. The x dt is still the same thing as v, velocity. So the x dt is equal to this. That means v is equal to 4t plus 12t cubed. Is that correct? So which means I can still differentiate this again. I can say the v dt will give me There's 1 here. When 1 comes down, it will be 4. 1 minus 1 will be 0. Anything raised to power 0 is 0, so t is gone. Plus, when 3 comes down, 3 times 12 will be 36. Then 3 minus, then that will be t squared. Do you understand that? So you differentiate the velocity again. The v dt now is the v dt. That is what? Acceleration. So now you will now slot in the time. 4 plus 36 into 2 raised to power 2. And that will give you the acceleration for the body. So whenever a body is expressed this way, and they say find the instantaneous acceleration, this is how you will do it. If they are giving you v directly, then you will just differentiate it once. That will give you the v dt, and that's all. But when they give you x, you differentiate the first time, you differentiate the second time, before you now slot in the value of time. Do you understand that? So that's instantaneous acceleration. Let's move on. So for your acceleration, the unit for acceleration, the unit is meter per second squared. That's the SI unit for acceleration, meter per second squared. And acceleration is usually treated as a vector quantity. So there's an argument on that, but it's usually treated as a vector quantity. So let's move on. So now that we know about all of these terms, the terms are S, D, or X. Remember what that means? That's distance or displacement. In our physics, we represent it with any of this symbol. That's distance. Then we talked about V, that's velocity. And we talked about U, that's initial velocity. This is final velocity, this is initial velocity. And we talked about A, that is acceleration. We even talked about negative A, that is deceleration. Then we talked about time. So all of these terms now, how do we relate them? How do we use them to solve problems? A car is moving at a particular speed under a given acceleration. What is the distance covered by that car? That means I know speed, I know the acceleration, I know the time it used to cover it. Then also I should calculate the distance that car has covered. So which means that I must find a way to relate all of these formulas if I want my problems to be solved. So let's see how the formulas are related. Then we call it equation of motion. So now, talking about equation of motion, there are actually 3 equations of motion, but we'll be working with 4. So the first one to work with is average velocity is equal to total distance over total time taken. We talked about that. We also said that average velocity can be calculated as velocity, the final velocity plus initial velocity over 2. You should remember these two. So now I can equate these two. I can say that V plus U all over 2 is equal to S all over T. Therefore, I can say that S is equal to V plus U all over 2 into T, if T comes to this side. So this one, let's call it equation 1. That's one of the equations we will need. When you have final velocity, initial velocity, time, and they say calculate distance, you don't have acceleration, you can use this formula. Now, the second formula we want to derive is that we already said, even from here, we said something. We already said that velocity, acceleration, we said acceleration is equal to change in velocity over time. Now, let's make V the subject of the formula. So we can say V minus U is equal to acceleration times time. Then we can say V is equal to U plus AT, if you arrange it very well. So U comes here, that becomes plus. Then rearranging, then we have this. So this is another equation. So let's call this equation 2. So V is equal to U plus AT. That's another equation we will need. Don't forget that. Then let's go on. This is the second equation. Let me be writing them on the side. So we have S is equal to V plus U over 2 into T. That's equation 1. We also v is equal to u plus at. That's equation 2. So let's substitute equation 2 into equation 1. And let's see. Let's bring what we have here. So we're going to have s is equal to, what's my v now? V is u plus 80. U plus 80 plus u all over 2 all into t. U plus u, that's 2u. So s can be equal to 2u plus 80 all over 2 then into t. So 2 here, let me do it this way. So 2u over 2, that's u plus 1 over 2, 80. So if I bring t inside now, like let me split this. This is what I'm saying. So I can say that s is equal to 2u over 2 plus 80 over 2. It's the same thing as what I have in that bracket. It's the same thing. So I can, this 2 and 2 can go. So this would be 1 over 2. So I can say s is equal to, if I bring t in now, u times t will be ut. T times t will be equal to plus, that's 80. So 1 over 2, 80 squared. So that's another equation. So this is equation 3. So don't forget that s is equal to ut plus half 80 squared. That's another equation we are going to be needing. Then the last one from here, let's substitute, let's make time here the subject of the formula. Yes, let's make time the subject of the formula. So if we make time the subject of the formula, so we're going to have t is equal to v minus u over a. So let's bring t here now. So we can say s is equal to v plus u over 2 into v minus u all over a. Is that taken? So let's simplify that. So we can say s is equal to v times v. That's going to be v squared. V times minus u. That will be minus vu. U times v plus vu plus times minus u squared all over 2 times a, 2a. I hope you're following. So now we can have back. So this and this will go. So we're going to have s is equal to v squared minus u squared all over 2a. So making v squared the subject of the formula, so we can say v squared is equal to 2a will come here, that would be 2as. Then u will go to the other side. Better still, so that I don't get confused, let's say 2as is equal to v squared minus u squared. So v squared is going to be u squared, when it turns positive, plus 2as. So that's the final equation. So let's call this equation 4. So these 4 equations will be useful. So we're going to have v squared equals u squared plus 2as. So these are the useful equations we need for equation of motions. And these are the ways to derive them. So now that we know this equation of motion, what are the important things we need to note before we start using them to solve questions on everything? So you need to note something. When a question starts with a body starts from rest, if the question says a body starts from rest, your u will be treated as 0. An apple falling from a tree, the apple was at rest, so you will be treated as 0. When the body says that a body comes to rest or halts, that means the body stops, or the body is coming to rest. So if the body is coming to rest, then v will be treated as 0. Please don't forget that. Another thing is that when the body is coming to rest, your acceleration is going to be negative. So it will be treated as deceleration, because the body is coming to rest. So it will be treated as deceleration. So don't forget these terms, we need them. And you remember something I said, when the body is undergoing uniform velocity, so if it's exhibiting uniform velocity, what will be the acceleration? Very good, 0. So you need to note that. So these are the important points you need to note before solving questions on the equation of motion. So now note all of these formulas. S is equal to V plus U over 2t. V is equal to U plus AT. S is equal to UT plus RVT squared. V squared plus equals U squared plus 2AS. So they can supply you any of these parameters in physics. Then they ask you to look for one of them, or you find a way to insert them into each other and get another thing. So let's move on to solving questions on what we have talked about so far. So a quick recap. I told you that motion is defined as the change in position of a body with time. And I said we classify motion into two, kinematics and dynamics. Kinematic is the study of motion without referring to the force causing the motion, while dynamics is the study of motion referring to the force causing the motion. And when talking about forces, we have contact forces and we have non-contact forces. Contact forces are those forces that require touch, while non-contact forces do not require touch. Examples of non-contact forces are the force fields, like the gravitational force, magnetic force, and electric force. Examples of contact forces are push and pull force, the tension force, the reaction force, the frictional force, or opposing forces. They are examples of contact forces. We talked about the different types of motion, where we talked about translational motion, the motion along a straight line, rotational motion, motion of a body about its own axis, circular motion, motion of a body around another axis of an object, random motion, haphazard movements of a body, random movements of a body, disorder movements of a body, that is called random motion. Then we also talked about oscillatory motion, which is the to and fro movement of a body about its equilibrium position. There's something called periodic motion. A periodic motion is a motion that repeats itself at regular interval. So we call it a periodic motion. It is more like simple harmonic motion, but they are not the same. All simple harmonic motion can be classified as periodic, but not all periodic motion as simple harmonic motion. So you need to note that statement. You will meet it as you move on. So now, talking about those types, we start talking about rectilinear motion, that is the motion of a uniformly accelerated body. Then after describing the motion of a uniformly accelerated body, we talked about the different terms we use in describing the motion of a uniformly accelerated body. The terms are your distance and displacement, speed and velocity, and acceleration. So under distance, I told you that distance is the total path taken by a body, while displacement is the shortest distance between 2 points. Your speed is talking about a scalar quantity not specifying direction, how fast the body is moving, while velocity is talking about how fast the body is moving in a particular direction. We talked about different types of speed and velocity, which is uniform speed or uniform velocity, average speed or average velocity, and instantaneous speed or instantaneous velocity. Then we talked about acceleration as the rate of increase in velocity with time, while deceleration is the rate of decrease in velocity with time. Then after talking about all of these terms, I explained how you can solve questions on instantaneous acceleration and instantaneous velocities. And that's all. Then from there, I derived the equation of motion that helps us to relate all of these terms. So the first equation of motion says that S is equal to, into brackets, V plus U over 2 into bracket T, closing the bracket. So then we also said that V is equal to U plus AT. Then we also said that V squared is equal to U squared plus 2AS. And we also said S is equal to UT plus half AT squared. So that's what we have talked about today. Let's solve problems on all of these things we have talked about. So we are going to solve quick 20 questions on all of the things we have talked about. So the first question says that, which of the following are contact forces? A, force of tension. 2, force of friction. 3, magnetic force. 4, force of reaction. We already told you that tension force, friction force, and reaction force are contact forces. Magnetic force is a non-contact force. So the answer is 1, 2, and 4. And that is option A. No, that's option B. So question 2. An object is said to undergo oscillatory motion when it moves where? When it moves to and fro. So A, when it moves in an erratic manner that is random motion. B, to and fro about a fixed point. Yes, that is correct. That is exhibiting simple harmonic motion. In a circular path, that is circular motion. Along a straight path, that is talking about rectilinear motion. So number 3, so uniform speed occurs when there is an equal change of what? Distance in equal time interval. Don't forget, uniform speed, it is change of distance in equal time interval, not displacement. So the answer is A, equal distance in equal time interval. Number 4, the motion of the bob of a simple pendulum. I already said it. A simple pendulum that keeps moving to and fro. What type of motion is it exhibiting? That is simple harmonic motion or oscillatory motion. So number 5, the term rectilinear acceleration. Rectilinear means along a straight line. Acceleration means change in velocity or increase in velocity. So the term rectilinear acceleration means the rate of increase in what? A, velocity along a circular path. No, not along a circular path. It must be along a straight line. B, distance along a rectangular path. That's wrong. C, displacement along a straight line path. That's wrong. D, velocity along a straight line path. Yes, that is correct. So the velocity moved by a body along a straight line path, that is rectilinear acceleration. Number 6, which of the following statements about speed and velocity is correct? A, they have constant values for bodies in motion. I leave you to answer that number 6 and drop the answer in the comment section. So let me know what you have gotten, so I will know if you are following the class through too. So let's move on to number 7. And please don't forget to subscribe before you leave. If you're here to subscribe to our channel, you are not helping us. So please try to subscribe. So question 7 says that which of the following types of motion is or are exhibited by a cylindrical drum rolling down an inclined plane? So for a drum that is rolling down an inclined plane, it's going to exhibit both translational motion and rotational motion. So the answer is, that's option D, translational and rotational motion. So number 8 says that an object of mass 2 kg moves for 5 seconds with a uniform velocity of 10 meters per second. What is the magnitude of its acceleration in meters per second? The question says with a uniform velocity. If a body moves with uniform velocity, what is the acceleration? The acceleration is 0. So you are not solving anything. Don't get confused. The moment you saw uniform velocity, then your acceleration is going to be 0. So that's what you picked. So if you start solving, you just be wasting your time. The acceleration is 0. Number 9, which of the following situation is not as a result of the application of a force? A, motion of a is not a result of application of a force. A, motion of a charge in magnetic field. When a charge is in magnetic field, it will be attracted or not. So let's say B, change of shape of a body. You have to keep beating the body and there will be a change in the shape of the body. C, a body falling freely under gravity is also under the influence of a force which we call gravitational force. Then D, motion of a body with constant velocity. So if the body is moving with constant velocity, the acceleration will be 0. So in that case now, there is no force applied. So the answer is D. Now number 10, the speedometer of a moving car reads what? We already said it. The speedometer of a moving car is going to read what we call the instantaneous speed or instantaneous velocity. So number 11, the average speed of an object is determined by dividing the sum of its initial and final speed by 2. Only when the acceleration is what? Only when the acceleration is uniform. What we have described is a uniformly accelerated body. So you're going to divide the average speed when you know the initial speed and the final speed. So that will be initial plus final divided by 2. That is what will give you the average speed. So that's what number 11 is saying. Number 12, a car travels at the average speed of 100 km per hour. Calculate the distance it covers in 10 minutes. Now, you are given the average speed, which is 100 km per hour. Note something, you must always calculate in your SI unit. Kilometer per hour must be converted to meter per second. So let's see how we're going to do that. So in order to convert to meter per second, it's very simple. So just know that your average speed, which is 100 km per hour, you will multiply that 100 by 1000 and divide it by 3600. That's how you do it. So if you do that, you're going to get 1000 all over 36. So that will give you the average speed in meter per second. This is in kilometer per hour. So you are converting it from kilometer per hour to meter per second when you do that. So now we already have the average speed. We are looking for distance, so we are looking for s or x, however it is. And we're given time to be 10 minutes. And don't forget, 10 minutes converted to second. So in order to convert it to seconds, that's going to be 10 times 60, and that's going to be 600 seconds. So now our average speed is going to be total distance covered over total time taken. So speed is going to be distance time, it's going to be average speed times time. So what's our average speed? That's 1000 over 36 times 600. So let's see what that value is. That's 1000 times 600 divided by 36. So that's going to be 16.666. 1, 2, 3, 4. So that's almost like saying 16 kilometer on approximation. So 16 kilometer if we have it, because the options are yes, the answer is actually 16. The answer is 16 like this meter. That's the answer. But for the option is in kilometers, so you divide by 1000 to give you kilometer. So that's going to be, if you have watched how we do conversion when we did our first class, you should know what I'm doing here. So this is 16.7 kilometer. So that's the answer. So now, number 13. An object of mass 4 kilogram moves with a uniform velocity of 20 meters per second. Calculate the magnitude of its acceleration after 10 seconds. So please do that for me. Let me see what your answer is and leave it in the comment section. Number 14. Which of the following is a random motion? Which of them represent random motion? 1. Pollen grain in water. 2. The molecules of hydrogen gas. 3. Fine chalk particles floating in water. All of them are random motion. Pollen grains in water, the water will be carrying them around in random pattern. And same thing with the second one. Gases, hydrogen gases will keep moving at random. Then fine chalk particles in water too, in here, will be moving at random. Here will be carrying them at random. So 1, 2, and 3 are random motion. So number 15 says that a car moves with a speed of 30 meters per second. Calculate the distance traveled in 30 seconds. I think that's a very simple question. Solve it and leave your answer in the comment section. Number 16. Calculate the total distance covered by a train before coming to rest if its initial speed is 30 meters per second with a constant retardation of 0.1. So let me help you to solve this. Now look at it. Calculate the total distance covered. So what you can do is just write out your parameters first. So let's write out our parameters. So calculate the total distance covered. So I'm looking for S. That's the first thing. By a train before coming to rest. So I said something. If something comes to rest, that means that V is going to be what? 0. So before coming to rest, V is 0. If its initial speed, so we're given the initial speed, U is 30 meters per second. With a constant retardation, that means the retardation is going to be minus 0.1 meter per second squared. You know why I'm adding negative there? Because that is retardation. So retardation, your acceleration will be negative. So now that you have all of these things and you want to calculate speed, you want to calculate this distance, which of the formulas are we going to use? Which of the 4 formulas? We have V, we have U, we have A, we have S. So the best formula to apply would be this formula. So let's do that. So we're going to have V squared equals U squared plus 2AS. So our V squared is 0 equals our U squared is 30 whole squared plus 2 into minus 0.1 then times S. So at the end of the day, this is going to be 900 minus 0.2 S. So 0.2 S, if you take this to the other side, 0.2 S equals 900. So S is going to be 900 divided by 0.2. So 900 divided by 0.2. So answer is 4,500. So our S is equal to 4,500 meter. That's it. So you can also do it this way in case you don't have calculator, then 9 times 10 raised power 2 over 2 times 10 raised power minus 1. Then 2 here and 2 here, 4.5. So that's 4.5. So when this comes up, it becomes positive. So that's going to be 10 raised, multiplied by 10 raised power 2 plus 1. And that's going to be 4.5 times 10 raised power 3. So 4.5 times 10 raised power 3 is the same thing as 4,500 because we move 1, 2, 3. So that means 4,500. So that's what you're going to have if you want to solve it in standard form. So number 17, a car starts from rest. If a car starts from rest, what will be the U? 0. You remember, a car starts from rest and moves with a uniform acceleration of 30 meters per second for 20 seconds. Calculate the distance covered at the end of the motion. I think you should be able to do that. Oh yeah, do that. I just did this one. So you too, you do that and leave your answer in the comment section. If you did not get the answer, I'm coming to your house. So number 18, a car accelerates uniformly from rest. This one is also from rest. That means U is equal to 0. Let me be writing it. So a car accelerates uniformly from rest. So U is equal to 0, A is equal to 4 meters per second squared. That's the acceleration. How far will it travel? Distance. How far will it travel in the 5th complete second? You have to be careful when you see a question like this. It's saying how far will it travel in the 5th. That means between 4 and 5. That's the time. In the 5th complete second. So you can do it this way. You are given, you are asked that between time 4 seconds to 5 seconds, how far did it travel between this region in the 5th complete second? So in order to do that, you will calculate how far it has traveled at 4 seconds, how far it has traveled at 5 seconds, and you can subtract it. You get your answer. Meaning that I can use, since you have U, you have B, you have S, the best to use will be this. Yes, we have time too. So we can say S is equal to U plus UT plus half AT squared. So now we can now say that S is equal to, this is 0, so we can say 1 over 2 times A, or A is 4 times 4 squared. So now that's going to be 2 here 1, 2 here 2. 4 squared is 16, 16 times 2, that's going to be 32 meters. So when the time was 4 seconds, it has covered up to 32 meters. Then when the time is now 5 seconds, that's also half AT squared. That's going to be half times A times 4 times 5 all squared. So I can say 2 here 1, 2 here 2. 5 here squared, that's going to be 50 meters. So when the time was at between time 5 seconds and 4 seconds, that's going to be 50 minus 32. And 50 minus 32 is going to be 18 meters. So the answer is 18 meters. But if you don't want to take this long process, you can also solve it this way. You can solve it this way. So you can say S is equal to UT plus half AT2 squared minus, or just say T5 for that time, T5 squared minus T4 squared. And that's going to be, our U is going to be 0. Then S is going to be 1 over 2 into 4 times 4 into 5 squared minus 4 squared. And that's going to be 2 here 1, 2 here 2. So that's going to be 2 into 25 minus 16. And 25 minus 16, that should be 9. So that will be 2 into 9. So my answer is going to be 18 meters. So that's how you solve it. So the next question, number 19. A motorcyclist traveling at 30 starts to apply his brake when it's 50 meters from the traffic lights that are just 100. If you reach the traffic lights, his deceleration is. So the motorcyclist was moving at 30 meters per second. Then he saw a traffic light. Then he started applying his brake. Then he's going to stop. If it's going to stop, that means v will be 0, u is going to be 30, then it's now going to cover a distance of 50 meters before it stops. That means the distance is 50 meters after you have seen the red light. So you are asked to calculate its deceleration. Do that and tell me what your answer is in the comment section, so that we'll be sure you have followed the class through. So number 20, a car moves with an initial velocity of 25 meters per second and reaches a velocity of 45 meters per second in 10 seconds. What is the acceleration of this car? I think that's a very straightforward question. You are going to use this. So you have v and you have u. So v is 45, u is 25, and you have t, which is 10 seconds. Now you have to, you are using this formula. You have v, you have u, and you have t, and you are looking for acceleration. So that's what you will use for number 20. Get the answer and tell me what you have gotten in the option. So those are the questions to explain the first part of motion to you. So we are through with rectilinear motion. So we'll be going on to motion, graphical motion, and motion under gravity in the next class. Then at the end of it all, we'll solve our past questions and make sure we understand it correctly and everything. So if there's any question, please leave it in the comment section, and please make sure you subscribe before you go. Leave comments and share with every other person that might need this video, especially those preparing for one exam or the other, or those still in secondary school, so that they can practice at home. Thank you. We'll see you in the next class.